clinicians and engineers tend to speak different languages. So in this case, I don't know why we have a construction engineer. It's meant to be a biomedical engineer. It's hard to know what do biomedical engineers wear. But yes, it's a biomedical engineer talking to a clinician. Yeah, this is an example where we develop a web application for monitoring epilepsy using EEG signal. We'll be using different explanations. So the engineer might say that we are using Fourier transform to decompose EEG signal into frequency components, filtering artifacts, so on and so forth, a wavelet transform. So we could use ChatGPT to essentially translate from one language to the other. Well, in this case, they're both English, but you know what I mean, the concepts. So translate the concept, and in clinical friendly language, it will sound like we are using methods to break down the brain electrical signals into patterns we can track over time. Yeah, I'm not sure why filtering is still used, but I guess, yeah, this will be filtering in a non-engineering sense, actual filtering, sifting through. So separating out normal activities like eye blinking or muscle movements, and this will help us focus on specific brainwave patterns that occur during seizures. So yeah, so it's so when translating engineering speech into a clinical friendly language, yeah, we're just essentially removing all the jargon. Yeah, ideally we don't want to start using more medical jargon, but if necessary, it's okay. But yes, it should be just more patient and clinical outcomes oriented. So go check out this blog. Yeah, and we actually have something similar blog that will translate the mental health concepts into engineering speech. So that could be handy if you are an engineer and you're interested in mental health issues. Then you will essentially have a blog translating mental health concepts into engineering concepts, giving examples. Yeah, so we have some examples of mental health concepts explained in terms of engineering tools. So you have things like feedback loops, signal to noise ratio, system overload, resonance and damping used to explain mental health. Yeah, also trying, I don't know if is chaos theory engineering concept at all or not? What do you think? It says yes.
Here's a list of engineering concepts that effectively bridge the gap between mental health and engineering. Hasher 1. Feedback control systems. Feedback loops in mental health mirror how emotional responses can either stabilize or destabilize us. Positive reinforcement is like positive feedback, while coping mechanisms act like negative feedback to maintain emotional stability. 2. Signal processing and filtering. Filtering helps separate valuable signals from noise. In mental health, this is akin to separating productive thoughts from anxious or negative ones. Mindfulness practices can serve as a mental filter to reduce noise. 3. Energy storage and capacitors. Capacitors store and release electrical energy, just as people store emotional energy, resilience, that they can release when needed. Emotional energy needs regular replenishment, similar to charging a capacitor. 4. Homeostasis and control systems. Homeostasis is a natural biological control system maintaining balance, temperature, pH, etc. In mental health, coping mechanisms are similar. They maintain internal balance, regulating stress levels and emotional responses. 5. Nonlinear dynamics and chaos theory. Mental health often follows nonlinear dynamics. Small changes can lead to major consequences, similar to how chaotic systems behave unpredictably. Understanding how small experiences ripple out over time helps explain sudden mood changes or shifts in mental state. 6. Parallel processing and concurrency. Handling multiple emotions, thoughts, or stressors simultaneously is like managing multiple concurrent tasks. Mental health is impacted by how well we manage these parallel tasks without overload, similar to an efficient multitasking computer system. 7. error detection and correction. In software, error detection and correction mechanisms ensure stable operation. Mental health coping strategies such as cognitive behavioral therapy, CBT, are similar. They identify negative errors in thinking and correct them to maintain well-being. 8. Overfitting and adaptability. Overfitting in machine learning means a model is too rigidly trained on specific data. In mental health, this concept can explain why people sometimes develop rigid, overgeneralized behaviors or thoughts that don't adapt well to new situations. Flexibility, like in well-regularized models, is key to adaptability. 9. Load balancing. Load balancing in engineering distributes work across systems to prevent overload. In mental health, this relates to managing stressors, distributing responsibilities, work, social, self-care to prevent burnout and ensure emotional stability. 11. Hysteresis. Hysteresis describes systems where the output depends on both the current and past inputs. Mental health operates similarly. Responses to stress or trauma are often influenced by past experiences, making reactions unique and highly dependent on an individual's history. 12. Resilience and material fatigue. Material fatigue is the weakening of a material after repeated stress. Similarly, mental resilience can be thought of as the brain's ability to withstand repeated emotional or psychological stress. Just like reinforcing a material to prevent fatigue, building healthy coping mechanisms strengthens mental resilience. These engineering concepts can help describe different aspects of mental health in ways that make the complex processes behind thoughts, emotions, and coping strategies more relatable. Using these analogies, we can see how maintaining mental health requires understanding dynamic systems, balancing inputs and outputs, optimizing energy, and ensuring resilience, much like any well-functioning engineered system.
So, in terms of, can we add more engineering tools and data, perhaps data visualization tools, data processing tools? One example is the knowledge graph. I don't know, another example could be the engineering concepts behind the music, or converting time series data into music by filtering. So filtering is another tool. Signal detection theory is another example. We could use machine learning as an example. Or more specifically, a convolutional neural network. I don't know if you can link it to mental health, that will be great. Yes, some EEG concepts in general should be linked to mental health as well. Use the concept of event-related potentials to explain mental health issues. Maybe throw in cross-coherence as well.
Concept: knowledge graphs, mapping mental complexity. Quick explanation. Knowledge graphs are tools that help visualize complex relationships by representing concepts as nodes connected by edges. In the context of mental health, knowledge graphs can map the intricate connections between thoughts, emotions, experiences, and environmental factors. For example, anxiety might be linked to sleep quality, social interactions, and work stress. Visualizing these connections helps see mental health as a network rather than isolated issues, enabling more comprehensive treatment strategies that address multiple contributing factors simultaneously. Questions to consider. 1. What kinds of relationships between mental health factors, like anxiety, sleep, social support, would be most helpful to visualize for someone struggling with anxiety? 2. How might understanding these connections help someone identify areas of their life they could work on to improve their mental well-being? 3. Can you think of any unexpected relationships that might be revealed by creating a knowledge graph of your own mental health experiences?